your own, great. Compare what you did to what I'm going to do. Right? So in example number 1, we are given one side, the hypotenuse, and we have to find the side of the two legs. First thing I'm going to do, copy down my standard 45, 45, 90 triangle on the left. I put my right angle, my other two angles are 45, they're the same, so I just use the tick marks. And I showed the lengths of the sides were what? What were the legs? 1, and the hypotenuse? Square root of 2. This should be drilled into your head. You should be able to write this on every single worksheet, every single assignment, every single test or quiz. Write this triangle down. This will be your reference point. It should go in your blue book. Not bonus points. This is like your basis. This is what you have to have in order to go from here. Right? So now we can set up our proportions. When I do this, I always like going from putting the new triangle on top of my fractions and the standard triangle on bottom. I write this as a reminder to myself. You can name the triangles A and B if you would like. You can name it new and old. Doesn't matter. But whatever you do, you have to have the same thing on top and the same thing on bottom as you go. I write it down as a reminder to myself. Okay? So on top, I'm going to do my new triangle. I'm going to look at the hypotenuse first. In my new triangle, the hypotenuse is 2 root 2. In my old triangle, the standard triangle, my hypotenuse was square root of 2. I have one fraction. Now I'm going to look at the legs. In my new triangle, the leg has a length of x. In my old triangle, or standard triangle, the leg has a length of 1. I have two fractions. Do these fractions have to be equal to each other? Do they? Are these both 45, 45, 90 triangles? So are they similar? So do the sides have to be proportional? Yes, so these fractions have to be equal. So I set up those fractions, those ratios. Now all I have to do is cross multiply and solve for x. So root 2, or 2 times root 2 times 1 gives me just 2 root 2. And x times root 2 gives me x root 2. These are equal to each other. How do I get x by itself? What do I need to take out from that side? The square root of 2. I can divide both sides by the square root of 2. There's not a lot of room here. I apologize for that. But when I divide both sides by square root of 2, I am just left with x is equal to 2. Just cross multiplying, that gives me 2 root 2 equals x root 2, but I want x by itself, so that's why I have to then divide both sides by root 2. Okay, questions on number 1? Let's look at example number 3. Nick, can you please take your headphones out? Thanks. Example number 3, again, I'm going to set up my ratios as the new triangle compared to the standard triangle. Could you do standard over new? You could, as long as you kept it that way the whole time. Okay? But I'm going to do the new triangle over the standard. Look at my hypotenuse. The length of my hypotenuse in the new triangle is x. In the standard triangle, it was square root of 2. I know that because I drew it off to the side. Should have it drawn somewhere when you do these. And if I look at the legs, in my new triangle, the side or leg length is 5 root 3. In my original triangle, my standard triangle, it was 1. So these two fractions have to be equal to each other. So to solve for x, I just have to cross multiply. X times 1 gives me x is equal to 5 root 3 times root 2. I'm going to write all of that out. 5 square root of 3 times the square root of 2. Is there a way that we can simplify those two different square roots? Think about what we talked about on Friday. Can we simplify those two different square roots that are multiplied together? What can we do with them? Could we add them? No. Can we multiply them? Yeah. When you have two square roots and you multiply them, you can combine them into one square root and multiply the numbers on the inside. So I'm going to rewrite this as 5 times the square root of 3 times 2 on the inside of one root, which is equal to 5 square root of 6. All right? You can leave your answer like this. This is called radical form because it has a root still in it. If it doesn't tell you to give a decimal or to round, leave your answer just like this, 5 square root of 6. All right, questions on number 3, on how we set up these fractions, how we set up the ratios. Number 4 is asking if there's enough information to determine if this is a 45, 45, 90 triangle. When we get to our quiz, you won't know. We're going to have multiple types of triangles. So your first job is to figure out if it is a 45, 45, 90. Is this triangle a 45, 45, 90? What do you think? You think yes? Why does it look like it probably is? We have our 90 degree. Did the other two look like they could be 45? They look like it. How can we know that they're 45 though? I agree that they look like these two triangles could be 45 degrees, but do we know that for sure? What else do we know about this triangle? What other information is up there?
What about your sides? Are they the same?
Two of the sides are the same. What do you call that type of triangle? If two of the sides are the same? Isosceles. If you have an isosceles triangle, then it means that those two angles have to be the same. Since our other angle is 90, then that does mean that these two angles do have to be 45 each. So this is a 45, 45, 90 triangle. So we could use our ratios, our proportions, to solve for the side lengths here. I'm not going to make us do it right now, but we could. Okay? So you may be asked to determine if a triangle is 45, 45, 90. So think about the stuff that you already know to figure out how you can determine that. Okay? Questions on the checkpoints. We're going to skip number 2. We're going to have other ones as class notes. All right, let's go on class notes. Next page. First thing I'm going to do. All of these triangles are 45, 45, 90 triangles. I'm going to draw my 45, 45, 90 triangle so I have a reference the whole time I'm working through these problems. I highly recommend that you do this as you're working today. On the top of your worksheet, this should probably be written down. My hypotenuse was a length of what? Square root of 2, and the legs were both 1. Pretty easy to remember. 1, 1, square root of 2. Okay? So number 1, set up my ratios. I'm going to do my new triangle on top, my standard triangle on bottom. So if I look at the hypotenuse first, in my new triangle, what's my hypotenuse? How do we find the hypotenuse? How do you, just looking at the picture, how do you know which one's the hypotenuse? It's across from the right angle. So what's the length of my hypotenuse? You may have to look at your paper, it's small. What's the length of that side across from 90-degree angle? X! Thank you. You are awake. Okay. My new triangle, the hypotenuse is X. In the standard triangle, the hypotenuse is always square root of 2. I can set this equal to a proportion I set up for the legs of the triangle. In my new triangle, each of the legs is square root of 11. In my standard triangle, the legs are a length of 1. Now I have two fractions equal to each other. Write this down. I can cross multiply to solve for x. X times 1 just gives me x. Square root of 11 times square root of 2. Again, if I have two square roots multiplied together, I can combine them into one square root and multiply the numbers on the inside. So my final answer will be x is equal to the square root of 22, or 11 times 2. Questions on number 1? Yes.
Would you get 1 under the square root of 11 at the top?
Yes. So here, I set up a proportion of the legs of my triangles. So I got square root 11 of the legs of my new triangle. The legs of my standard triangle are just 1.
You're always going to use that triangle.
You're always going to use the 1, 1 square root of 2. On any 45, 45, 90 triangle, that's why I would write this little triangle down every single time. This is always what you are going to use to set up your proportions, to set up your ratios. Okay, other questions on number 1? look at number 2. No? Question? With all of that, writing it down? The extra stuff at the bottom? All the circling? How you cross multiply? Okay, some people, if you don't cross multiply like that, that's fine. Some people learned it that way, but if you don't do it that way, that's totally fine. If you just know 1 times x and square root of 2 times square root of 11, that's fine. Yep. Yeah. So getting the idea that these triangles are similar and you can set up proportions is a little bit to wrap your head around. But once you get that, solving for x is not very difficult. Okay? Let's look at example number 2. Is this a 45, 45, 90 triangle?
No.
Is it?
Yes.
Does it tell me that the angles are 45 degrees?
Can you figure it out?
Doesn't. What do those angles have to be? What does it tell you about the angles? They have to be acute because the one is 90. But what else is true about those angles? They're equal to each other. Guys, wake up. I know it's true, you're outside. You gotta stay with me. I don't want to lose you. We do have a quiz on Thursday. Okay? So if those angles have to be the same, and our other angle is 90 degrees, they both have to be 45 degrees. Okay? So since they both have to be 45 degrees, our first question is to find x. How do we find x? Perfect, Caitlin. Since we know that angle has to be 45, since they're both the same, and we have a 90, then we can set 5x equal to 45, divide both sides by 5, and we get that x has to be equal to 9. Okay? That was what it was asking us to do. We can also solve for y, our missing side. I'm going to erase all the stuff I drew inside the triangle so I don't get confused. Okay? To solve for y, we know now that this is a 45, 45, 90 triangle. So we just got to set up our proportions. In my new triangle, my hypotenuse here is 30 root 2. What is my hypotenuse in the standard triangle, Harrison? Do you have your standard triangle drawn on your paper? Draw it. Look at the standard triangle I have written on the board. What's the length of the hypotenuse? Can you see it? The one in the bottom left corner. The little bitty one.
2.
Square root of 2.
Yes.
Make sure you don't forget that square root. Okay? So I have a ratio of my hypotenuse in each triangle. I can look at the legs now. In my new triangle, the leg is labeled y. That's what we're trying to find. In the standard triangle, what is the leg length on a 45, 45, 90? Justin. Standard triangle, what's the length of the legs? 1. It's always 1. You're always using the same thing for your standard or your original triangle. Call it whatever you want. You're always using the same thing. So that picture should always be drawn on your page so you have a reference. Alright? All we need to do now is cross multiply. I won't draw the arrows this time to confuse you, Monica. Alright? So, 30 root 2 times 1 just gives me 30 square root of 2 is equal to y times the square root of 2. How can I get y by itself? Divide both sides by square root of 2, which conveniently works out for me to leave me with y is equal to 30. Yep. Yeah, that's fine. Okay. Questions on number 2.